Hi everyone, congrats on making it to day 16 of Advent of Cyber. My name is Melanie, or Melmos, and I create DevSecOps content at TryHackMe. Yesterday we explored Active Directory, but today we're shifting the gears and diving into the world of cloud and a little bit of cryptography, so let's get started. Okay, so today's challenge is called the Wareville's Key Vault grew 3 sizes that day. Another day, another challenge, and unfortunately for McSkidy, another intrusion in their Azure tenant. Before joining McSkidy in her investigation, there is some catching up to do, and this is a story best told in rhyme. And this is a story I'll let you read on your own because this poem is slightly long. But from reading, it seems like McSkidy, even though she's super tired and burned out, she's so dedicated that she pushed through. And after having some coffee, her brain cells started functioning again, and she started getting to work with Glitch to figure out what happened. Apparently somebody managed to find a way to their Azure tenant, an intruder. So let's keep going. What are we learning today? We're learning about Azure services like Key Vault and Microsoft Entra ID, and we'll be interacting with these services using an Azure Cloud Shell, which is a terminal that's browser-based. Intro to Azure. So before diving into the glitch's idea of the attacker's path, let's introduce some of the key concepts that will be covered in the process. Cool. The reason why McSkidy used Azure is because she wanted to host her web application to handle appointment making and run some virtual machines for investigation and evidence storing and analysis. But because she was managing these things on-prem, she wanted to figure out a way to make it more scalable and stop worrying about the maintenance, which is pretty much how cloud service providers started. Back in the day, companies had to maintain servers physically on-prem for hosting their product, their websites. But the thing with this is that if you wanted to use 25% of the resources, you still had to pay for all of it. And it was a bit of an overkill. So picture a store that sells items online, and maybe throughout the year, they're hosting it by using 30% of their resources and computational power. But then days like Black Friday or Boxing Day happened and their traffic would spike. So they would need to scale. Hence why they would need to buy so much resourcing for these days. But when it comes to cost optimization, it's not frugal and it's not maintainable. And this is how cloud service providers were born. They're able to give you computing resources on demand, so you pay for what you use. And you also don't have to worry about the physical maintenance of these servers. That's something there's a shared responsibility model, and that's something that they take care of for you. So it's pretty neat. And I can understand why McSkidy wanted to move her services to Azure. That way she didn't have to worry about all these things. There's other cloud service providers, like it mentions there. You have Google Cloud and AWS. Those three are the most popular ones, I guess. But you also have Alibaba Cloud and others that are slightly smaller, but still used across the globe. There is about 200 services at the time of writing that Azure can provide you. These are spread across different areas. You get machine learning, big data analysis. I think they're also starting to release quantum computing services. So yeah, it's pretty hard to keep up with all these, but luckily for us today, we're just focusing on a few of them. We have Azure Key Vault, Microsoft Entra ID, and Cloud Shell, which I guess we'll use to interact with these later on. So what's Azure Key Vaults? It's an Azure service that allows users to store secrets. Yeah, so it's what you called a vault. You might have heard of HashiCorp Vault, for example, but Azure Key Vault is a specific vault offered by Azure, which means that is not cloud agnostic. You could be using HashiCorp Vault if you have a multi-tenant environment. If you're using AWS or GCP as well, it makes sense to use a vault that could sort of interact with all these. But if you're performing encryption or building a service and you rely only on Azure, it makes sense to use Vault. Like it says there, you can store different types of objects. It gives you 3 options. It gives you the ability to store a secret, a key, or a certificate. Each one of them have some intricacies. So for certificates, you're able to generate or import a certificate object. So if you did day 14 of Advent of Cyber, we dived a little bit into the components of a certificate, and it has a key pair, a public key and a private key. So it allows you to store an object with that pair and the metadata. Whereas in a secret, you might be able to store just a private key or just a public key, or an API key. It depends what your use case is. Or if you want to store it as a key object, that means you can store certain types of keys. So Azure allows you to generate a key within the key vault, which is pretty neat if you don't want to take the key out and if you're using it to encrypt a database, for example. And it gives you the option to generate, for example, an RSA key with different sizes. If you're dealing with a database that has highly confidential data and you want to perform encryption with, say, an RSA key of a larger size, and you want it to generate it with a module that has high levels of randomization, you can also pay a little bit more and get a premium key vault, which is backed with an HSM, a hardware security module, which is a type of device that allows you to generate keys with high levels of pseudo randomization. Without getting too much into this, sometimes when you generate a key in your laptop and you sort of type in your keyboard or you move your mouse, you're actually helping improve the randomization of that key because your laptop has certain types of modules that uses those inputs to randomize the generation of the key. But yeah, pretty cool area. I suggest you research about it after you do the task or during the task. And then we have Microsoft Entra ID, which is formerly known as Azure Active Directory. You might have sort of known about this from yesterday's challenge, but it's an identity and access management service. And you use it to assess whether a user or an application can access a resource. Assume breach scenario. Knowing that a potential breach had happened, McSkidy decided to conduct an assume breach testing within their Azure tenant. The assume breach scenario is a type of penetration testing setup in which an initial access or foothold is provided, mimicking the scenario in which an attacker has already established its access inside the internal network. Okay, so we've already assumed that there's been an intrusion. So unlike other penetration testing frameworks where you're figuring out how to breach or enter an environment, this has already happened. So we're just figuring out how far they can get with their initial access. What are we needing today? We are using a direct link and cloud credentials. We don't need the attack box or a VM. So there's not going to be split screen. Makes sense. Let's get the cloud details. I think you have a guide on how to connect to the Azure tenant here. So let's click the cloud details, join the lab. It will load in a second. If you click the Open Lab button, it should prompt you with the Azure login portal to enter your credentials. Let's do that. Here we have the portal. Let's copy the credentials. And the password. It's going to ask you to set up MFA. You should always set up MFA, but for the purpose of today's challenge, we're going to skip. But if you're doing this on your personal account, always click next to set it up. Press cancel and ignore it. You're able to set up your language in the language and region tab. Because we're doing today's challenge in English, I'm just going to leave it as it is. But feel free to customize if you need to. Okay, let's go back to the guide. We've done all of this. Great. Azure Cloud Shell. Azure Cloud Shell is a browser-based command line interface that provides developers and IT professionals a convenient and powerful way to manage Azure resources. Yeah, that's right. Like mentioned earlier, it's just a terminal you spin up in your browser. It integrates both Bash and PowerShell environments, allowing users to execute scripts, manage Azure services, run commands directly in their web browser without needing a local installation. Yeah, it already has some built-in tools that we're going to be using today. One of them is the Azure CLI. So think of it as a toolkit, an SDK that allows you to interact with Azure resources. We have over 200 resources in Azure, like we found out earlier. So you can have specific commands to interact with these. We're using Key Vault today, so we're going to be using Key Vault commands. If we want to list the secrets or we want to check the access the Azure Key Vault has, we'll be using the Azure CLI for that. All right, let's spin up the Cloud Shell. You can find the button in the top right corner. It's going to prompt you to select your environment. I am going to select Bash because I'm not crazy. You don't have to mount storage. We don't need to persist any of the commands we're running today. However, if you want to give it a go and have a personal account, you can select to mount to storage if you want to keep the history of the commands you're running, or you want to keep track of your session, come back to it later on and run the same commands or do some scripting. There's already a subscription created for us for today's challenge. We're going to select that one. Click apply. It should take a few seconds, maybe a few minutes for the shell to boot up. And look at that, almost immediately we have a shell. Let's go back to the guide. We've done all of this. We're ready to execute Azure CLI commands. Note that all the following commands are to be executed in the Azure Cloud Shell. We can run this to check our current user. Should be the one we authenticated with at the start of the task. And yep, that's the one we've logged in with. All good. Note, you don't need to authenticate using AZ login as you have already been authenticated into Azure portal. Yeah, that's right. So we're in the same session that we've authenticated with, and we're booting it up within that session. So we don't need to perform that command. But if you want to authenticate through your own terminal in your laptop, then you're going to have to authenticate like how we did earlier in the portal, but programmatically through that terminal. We've confirmed the credentials, so all is well. Going down the Azure rabbit hole, when Glitch got a hold of that initial account in Wareville's Azure tenant, he had no idea what was inside it. He decided to enumerate first the existing users and groups within the tenant. Makes sense, so let's check which user accounts are in this tenant. We can do AZ AD user list to get all the users. If there's quite a lot of users, this might take some time. So AD stands for Azure AD or Entra ID. User is the AD users, and the action is to list all of them. We can specify what accounts to look for, like McSkidy is suggesting to do there. So let's do that so it doesn't take that long and we can sort of filter out the results. So we're now adding a few flags. We're adding the filter flag with a condition that it starts with this string. So WVUSR, and display the name. Okay, let's copy that. And it's still loading. There are the results. There's quite a lot of them. So let's filter them out. Wayland. Wayland and Yutani. Some alien Easter eggs there. Great movie. All right, let's filter out. Yeah, so we got all the WVUSR, Wareville user. You may observe that an unusual parameter was set to a specific account in the output. Backup where has a password stored in one of the fields. Ooh. Where is backup where? Ah, there it is. The office location is recover secrets. This is a pretty weird office. I think this is a flag, which reminds me, let's check the questions. What is the password for a backup where that was leaked? We just got that. Should be recover secrets. Group ID of the secret recovery group, name of the vault secret, and contents of the secret stored in the vault. Okay, we don't have that yet. Let's go back. When Glitch saw this one, he immediately thought it could be the first step taken by the intruder to gain further access into the tenant. However, he decided to continue the initial reconnaissance of users and groups. Let's list groups now. We got the users. Makes sense to list the groups. This was much quicker because we only have one group, and it's called the Secret Recovery Group. Group for recovering Wareville secrets. Nice. Okay. We changed the previous command from ACAD user list to ACAD group list. So instead of listing users, we're listing groups. Yep. We found out about the secret recovery group, which is pretty interesting based on the description. Let's follow the white rabbit and list the members of the group. Yeah, let's do that. So we're now gonna list the users within a specified group. Let's copy the command. And backup where is part of this group. It shows the office location and the ID. Okay, makes sense. We got asked for an ID earlier, so. What is the group ID of the secret recovery group? Okay. If we go back to the group list command where it listed the ID of the secret recovery group, you can find it in one of the fields here. So I'm assuming is this one. Nice. What is the name of the vault secret and the contents of the secret stored in the vault? Let's figure out which vault we have access to. Given the previous output, it looks like everything makes sense now. All the previous commands seem to point to the backup where account. We've seen a potential set of credentials. Let's jump to another user by clearing the current Azure CLI account session and logging in with the new account. Okay. Let's clear and log out from our session. Right, we've logged out and now we can log in with the backupware user. We got the password earlier, recover secrets. And the email, we have it there as well. Backupware at AOC 2024. And we've logged in as backupware. Since the backupware account belongs to the recovery group, Glitch first hunches to see whether sensitive or privileged roles are assigned to the group. It doesn't make sense to name it like this if it can't do anything, right, McSkidy? Yes, absolutely. Include me in the discussion. I agree. Before checking the assigned roles, let's have a quick run through of Azure role assignments. Azure role assignments define the resources that each user or group can access. When a user is created via Enter ID, it cannot access any resource by default due to lack of role. To grant access, an administrator must assign a role to let users view or manage a specific resource. The privilege level configured in a role ranges from read-only to full control. Group members can inherit a role when assigned to a group. Okay, so with RBAC, role-based access control, you sort of give the user a set of permissions depending on that role. You can have a read role where all you can do is view or read objects or resources. Or, you can sort of widen the scope. I think the contributor role in Azure gives you power over lots of actions, list, write, delete, things like that. Group members can inherit a role. This is pretty important. So if you give a group a set of permissions and you add a user to that group, they automatically inherit those permissions. So I'm guessing backupware, because he is part of the secret recovery group, he's gonna have some interesting permissions there. Let's return to the Azure enumeration. And let's see if a role is assigned to the secret recovery group. We will be using the flag all option to list the roles within the Azure subscription, and we will be using the assignee option with the group's ID to render only the roles related to that group. Makes sense. Let's see what backupware can do. Let's copy that. So we got the ID earlier, and it was part of the questions asked. In the AD group list should be the ID. There it is. Let's copy that. We have two roles. We have the Key Vault Reader and the Key Vault Secrets User. Okay. In this scope, you can see where this role applies to. Within our resource group, there is a key vault called Wareville Secrets. So we have reader and secret user in this vault. So we got the name of the vault now. So this is why RBAC is so powerful. You can create specific roles at a very granular level. So remember when we spoke about the different types of objects you can add to a key vault: certificate, secret, and key. You can also create RBAC roles where it only lets you interact with one type of object, for example. So we have the Key Vault Reader. We can list the contents of the Key Vault, but we can only interact with the secret objects, with the secret user group, which is pretty cool. All right, let's test this out. We've retrieved the group ID. Let's break down the outputs. There are 2 entries in the outputs, which means 2 roles are assigned to the group. Yep. And we figure out that it's Key Vault Reader and Key Vault Secret User. And it points to the Wareville Secrets Vault. Here you have the scope of the roles. You can also find it in the Microsoft documentation page, but like we said, the Vault Reader allows you to read the metadata and list the objects of the vaults. So all of the types: certificates, keys, and secrets. it could be that it says Key Vault certificate view only role or something like that, where you can only list certificates, but in this case it's a bit more generic. The Key Vault secret users can read secret contents. Only works for Key Vaults that use the Azure role-based access control permission model. Ah, that's interesting. So older versions of Key Vault have access policies, which is being deprecated, and we're moving away from that. But you could set access policy instead of roles. That means that you had to manually add a user to a group and you gave that user permissions. So you would have to manually configure, I guess, a specific role in that sense to that user. This is quite annoying because if you have to do user management and you need to keep adding or removing users, you're also removing the permissions with them. Whereas now if you configure a group and you just add that user to that group, you don't have to worry about setting up the permissions. You don't have to sort of figure out if they need only read access or they also need more powerful access if they are, I don't know, a crypto officer or an engineer that need to like troubleshoot and list the secrets or do testing. So if you create a group and you just add the user to that group, you automatically assign them the roles. So this is one of the benefits of RBAC as opposed to traditional access models. And yeah, we can read the contents of the Key Vault secret objects. After seeing both of these roles, McSkidy immediately realized everything. This configuration allowed the attacker to access the sensitive data they were protecting. Now that she knew this, she asked Glitch to confirm her assumption. All right, let's list the Key Vaults we have. We've already found out that it's called Wareville Secrets. Well, we can run a command to confirm. So we are listing the vaults. There's only one. Wareville Secrets. And then the next command we can run is the AZ Key Vault secret list. So we pass the flag of vault name to specify to list the secrets in that vault. Let's do that. What's in there? So there is one secret called AOC 2024. Let's see the contents of that secret. So with the command secret show, we can see the contents, and we just need to pass the vault name and the name of the secret we want to view. And there it is a password. Where is my mind? Great song by the Pixies. I'm not sure it's from 1999. I think it's 80s, late 80s. Okay, I think this was one of the questions. Yep. What are the contents of the secret stored in the vault? Where is my mind? And the vault name is AOC 2024. Nice. And bingo, the glitch exclaimed as he saw the output above. McSkidy had confirmed her nightmare that a regular user could escalate their way into the secrets of Wareville. With that, the glitch had helped McSkidy to find the attack path, and that had been taken to escalate user privileges, and a lot had been learned in the process. The question remained was who had initially carried out the attack in the first place. There was a very limited set of wearers who had access to this tenant and with user visibility. And with that set of permissions, only town officials who perform governance validation on the tenant to ensure all the town's secrets are being stored securely. Could it be the mayor? Who knows? That was a really fun challenge. You can check the exploiting Active Directory room to practice user group enumeration in a similar yet different environment. Absolutely. There's also the CryptoOps room. It's a DevSecOps room, and it introduces you to HashiCorp vaults. Also pretty fun, but it's not cloud specific. It's an independent tool on its own, but it follows a similar style of having a vault and a secret, and the way you interact with it is very similar to the Azure CLI SDK. I hope you learned and enjoyed today's walkthrough as much as I did. It was a pleasure making this video for you, and good luck for tomorrow's AOC challenge.